This conference will now be recorded.
Thank you so very much, madam. So, dear friends, the topic is Cisco ACI. As I said, the intention of this session is not to teach because one single day cannot be covered, right? To cannot cover the entire 1 month process. So, but it is always good to know the overall picture of what is there in Cisco ACI. Well, Cisco ACI is a vendor specified terminology. The name of the technology is called SDN, which stands for software defined network. Well, this seems little confusing. What is this? What Cisco has done is Cisco said that this particular technology we are going to introduce with absolutely a new set of devices, with a new set of operating system, which is configurable not only with CLI, but with the automation, with the GUI, with various other tools, right? Now, the name of the technology is called ACI. ACI stands for Application Centric Infrastructure. As software defined networking talks something about, yes, we are talking something about network. The details of ACI, if you see the acronym ACI in an expanded form, which stand for application centric infrastructure, it doesn't talk something or anything about networking in the name itself, but it is very much related to the networking. But the networking which is going to be concentrated towards application centric. Now the big question for our network engineer comes is, what is this network centric? This is one of the approach. Application centricity is one of the approach of configuring our switches. Those friends of us who have just completed VXLAN and they are moving over to ACI. For them, understanding the topology of connecting the switches in ACI will not be a big challenge to understand. Anyway, in this particular journey, what we are going to talk about, I would like to cover that first of all. In this long journey, we are going to talk about the technology. Before technology, it is always good to understand the topology where we are going to work on. The topology is having two aspects. One aspect is known as physical aspect of the topology, and second is known as logical aspect of the topology. So this is an important catch point over here. So when it comes to ACI, we should know how the devices, how the switches, ACI switches they are connected to, which is called physical topology. And when it comes to functionality, right, it is the logical topology. My dear friends, in this particular journey, besides learning about the physical topology, logical topology, it is very, very important for us to understand the concept of network virtualization. Virtualization. The concept of network virtualization, and specifically the one which was introduced by VMware. So we are going to understand the concept of network virtualization. But even before that, in this particular journey, we will be learning what is server virtualization concept. You know why? It is simply because of the reason our physical topology is going to do a handshake, that is our ACI is going to do a handshake with our VMware infrastructure. We are going to see over here how and what is it. You know, this is based totally on a lab and the hands-on. Right. Now, once we are comfortable with this, then definitely we will work around on so many labs. I'll show you what different labs we will be working on. When it comes to the labs, I would like to divide the labs into the two major components. One are called basic and other labs are called advanced labs. When it comes to basic labs, these labs are there, very important for us. And you know, these basic labs are going to cover approximately 80% of all the labs. These advanced labs, what we are going to cover, they are going to be just 20%, and only in the advanced scenarios that these labs will be covered. The question comes is, what are these advanced labs? Advanced labs means where we will be talking about advanced ACI topologies like multi-pod and multi-site. Dear friends, in this particular journey, definitely we will face certain challenges with regards to the labs, and that is, for example, multi-pod lab. We will not be able to do hands-on because the infrastructure is not available. So those challenges, when there are challenges, we are going to mitigate challenges by going more in detail and in depth in order to understand it. So for that, yes, the lab workbook will definitely help you to do understand what and how to configure the ACI multi-pod. In multi-site, we are going to do hands-on. I would like to take a short pause over here because this is just a high level understanding which I'm trying to give you. I would like to take a short pause so that you can ask some questions which I may answer right now, or I may park them to be addressed in the sequential flow. So, any questions if you, dear friends, have? All right. You guys are welcome to ask any question in between. Siddhant, Syed, Louise, all of you guys. Okay, here we start. We are going to discuss about so many new terminologies. We are going to come across so many new acronyms over here. The moment if you feel that one specific terminology is not getting clear, guys, you have full right to stop me. I will try my level best to make sure that new terminologies you are definitely become comfortable to. Here in this particular journey, we are going to interact with some new protocols as well. We are going to look at into the protocols from predominantly from control plane perspective. Dear friends, in this particular journey, the so many protocols we may not be asked to configure. In fact, indeed, the various control plane protocol, for example, VXLAN, for example, multicast, for example, ISIS, for example, BGP, for example, OpFlex, for example, these different control plane protocols. And you know what? We need not configure any one of these control plane protocols. So don't worry, there will be no ambiguity. Talking about so many control plane protocols, and then you are saying that you need not configure it. So there comes an ambiguity. So dear friends, don't worry, there will not be ambiguity because we are going to understand the functionality of each and every protocol. And you know what? ACI, the one which we are talking about, is very much an automated technology as well, which means by doing certain basic configurations, various control plane protocols gets tweaked in and they start working automatically. It is good for the purpose of, from the point of view of troubleshooting, that we should know how these protocols are working. But the topic which we are doing, the ACI which we are doing in Cisco, we call it as the course called DCACI, which is predominantly an implementation course. This course is not going to cover a lot in depth about operations and troubleshooting. And I'm sorry, my pen is not going so smoothly, maybe because of the internet connectivity. So I'm sorry, it is DCAC and then this is I. So we will be doing these sessions from the point of view of the implementation, that is how to configure. Operations and troubleshooting we are not going to cover, but a part of the troubleshooting I will definitely cover on some special request. Whatever is the part of the troubleshooting which is nothing but which is a deep dive understanding of how the traffic flows in between the ACI switches, I will cover once we will do the basic labs on the request. So I'll tell you that, see, this is what I'm not going to cover. Please make note of it and please do ask me once our basic labs are done so that I can show you how the internal traffic flows. And anytime, in case if you need to troubleshoot, instead, or if you hire Cisco TAC to troubleshoot some of your issues, and if you monitor it, you will be able to understand what troubleshooting they are doing. Most of the time, the deep dive troubleshooting, Cisco keeps this in their own hands with the tech team. Okay, any question? Well, very first question is, you know what? Why ACI? You know what, guys? Today you go to any network. All the networks, either they are already running ACI or the data center I'm talking about. If not, then they are migrating to ACI, right? I'm not sure if you people are working on it, but the future is indeed ACI. And I can confidently tell you that there is no alternative of ACI as of now. Yes, if you say VMware is providing us NSX, T solution, so many advanced solutions, but all these, besides having all these solutions, the transport layer, right, meets with the application centric infrastructure itself. So once we'll do it today, if you talk about Amazon Web Services, if you talk about Google Cloud, if you talk about any public or private cloud, all are based on application centric software defined network infrastructure. Okay, now ACI is there to minimize the network operations tasks. The traditional network operation tasks, they will get, once you will look at into ACI, you will see how ACI helps to minimize the network operation task of finding the faults, of monitoring the faults. That means if you talk about two of the libraries, alarm libraries and performance libraries, these two libraries are getting catered by our ACI itself. So instead of, say, any of your monitoring tool, if you have, now today, instead of fetching the details from each and every individual switch, by this monitoring tool, what he can do is he can fetch the alarm libraries, performance libraries, alarm libraries right from one single tool, and those can go to your monitoring tool or say any SNMP tool. So our network operations become more easier. So if the details can be fetched from one single point of contact, it becomes faster to create the tickets based on the severities can be done. Of course, the network engineer finds it more easy. If you are a typical network engineer, then now you have to move out of from the typical three-tier architecture of what? Of core, distribution, and access model. In ACI, we do not call core, distribution, and access layers. At a rough high level, you can say ACI from the topology point of view, that is physical topology point of view, is nothing but it is just a two-tier architecture. Two-tier instead of typical three-tier architecture. One more thing, in this two-tier architecture, ACI makes sure, the ACI topology makes sure that none of the port goes into the blocking state. As we know, in our three-tier architecture, spanning tree protocol gets activated, and once it finds the redundant loop, it blocks one of the port. No such over here. And I'm sure my friends who just completed VXLAN to yesterday, they can understand, because this architecture in ACI is based on the same leaf and the spine architecture. There is no possibility of any loop. And you know what? In case by mistake, if any one of the engineer connects them, and in case if the loop happens, in the course of our configuration, I will stress you guys upon to configure one of the protocol, and that protocol in itself will take the responsibility to make sure the loop doesn't occur because of the cabling, miscabling. All right, I am still going at a very high level. I would like to come back to you people. please, if you have any query, question, if anything is going above your heads. Pitabas, Raj, Sampath, Siddhant, Syed, Vasu, guys. I'm extremely sorry if you
Okay,
feel like. Yeah, Vasu.
so yeah, I have a question. So the
Please.
question now is so the normal topology is the switch at the bottom will not have direct connection to each other. Rather, they will be connected to the switch at the top, which is what do you call it? Is this spine and leaf?
Mm-hmm. That
So
is right.
now I want to ask, is there any case whereby that will necessitate connecting those switch at the bottom together?
Good question. And probably if I have understood your question correctly, let me answer the question. First of all, you have to tell me whether my understanding to your question is correct or not.
Okay.
First of all, the ACI topology is a two-tier topology. Where the upper layer switches are known as spine switches. This is called spine switch, and the lower layer switches are called our leaf switches. Leaf, 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 and leaf. The connectivity is like this, that all the leaf switches are connected to all the spine switches and vice versa. There is no leaf to leaf connectivity, there is no spine to spine connectivity. Now, your question, if you have understood it, and please tell me, Vasu, if my understanding to your question is correct. Then now your question is it possible that by any chance these devices can be connected to each other? So first of all,
Exactly. That's my question.
that's your question. And the answer to your question is yes. It is possible. First answer to the question should be no, you should avoid doing it. But the holistic and the real practical answer to your question is yes, it is possible. Then the next question comes is how? And the answer to this how is VPC, virtual port channel. So dear friends, if you know what is virtual port channel concept, right, then I will say answer is yes. If you do not know what is this virtual port channel and how do we do it, in fact, this VPC, right, we have covered previously in the long journey which is currently going on called CCIE data center journey. So Vasu, my dear friend, do you have some understanding about this topic called VPC, virtual port channel?
Yes.
Yes.
So
So
like a kind of connection coming from two different switches going to a particular switch. But those two different switches, the switch connected to them are seeing it as one. Am I correct?
absolutely. This means these two particular switches, say leaf 1 and leaf 2, by the virtue of using VPC, you know what? We can present them as one single logical entity. If we are ready to present these two physical boxes, these two physical switches as one logical entity, and then the answer is yes, it is possible. If you are not ready, then the answer is no, it is not possible. One more question comes in the sequence. And the question is, are we going to do it? in our labs? And my answer is yes. I'm going to cover this in the lab. Vasu, does it answer your question, my friend?
Perfectly.
Thank you so much. I really appreciate and admire, asking questions. Even my teaching becomes so much of monotonous that even I feel bored. But your question, they further energized me, right? And from your question, even I learned something. I am not 100% expert. Yes, please.
Yeah. So in addition to this question, right, like if you make it a VPC,
Yes,
so
Raj.
will there be 2 leaf switches or it will consider as 1 leaf switch?
Physically, there will be 2 leaf switches, but logically, they will present themselves as a single leaf switch. To whom? To the device connected to them.
But to
If
the
it is
spine,
server,
it will be to the spine?
to the spine, it will be 2 leaf switches. Spine will not consider
Because
them
there is
as a
no
single.
VPC. Okay.
Yes, because between leaf switches and the spine, there is no VPC. They
Okay,
are.
so
Please.
sorry, this is Wasi again. I want to ask a question. Sorry to interject. So
No
the
problem.
question
Go
now
ahead.
is if they are in VPC, in which the 2 switches, I mean, the 2 spine switches, is seeing them as 1 switch, right? So how many cable will be connected to the spine switches? Is it still 4 or 1 or 2? I don't know if you still understand my question.
50%.
Physically, we have 4 cables from these 2 so-called switches in VPC, right? 2 cables from each goes to the spine switch. My question now is, if they are in VPC, are we still maintaining those 4 cables, or we reduce it to 2? Since the other switches is seeing them as 1.
Okay. Before you, Raj was asking a question, and let me give answer to the same question once again. His question, Raj's question was, when we connect these 2 leaf switches and when we make them as one single logical switch, will these 2 switches be seen by the spine switch as one single or 2? And my answer was, VPC is, that is, these 2 physical switches are logically presented to this particular server as 1 and not as 2. But VPC is not built towards the spine switches. VPC is not built towards the spine switches. So spine switches, they will see them as 2 separate switches. This was the answer to Raj's question. Now, Vasu, I'm trying to understand your question. Your question was about how many interfaces currently.
So, actually, you've answered my question. Sorry. You've answered my question in the sense that you said VPC is built towards the connecting client, which is endpoint, not towards the spine switches. So I think you've answered my question.
Thank you so much. That's the reason I answered once again Raj's question, because I thought probably in that there is answer to your question. Highly appreciated, Mazio. Thank you so much for asking this question. Once again, I would like to say, guys, by asking the question, not that you are helping yourself, but you're helping others. So it is very philanthropist, act of yours by asking questions. So I highly encourage you.
Yeah, absolutely. Thank you, Raj and Vasu. You are increasing our knowledge levels also and getting into a different thought process. I appreciate it. And
Sir,
one
I have
question
one
from my
question, sir.
side.
Please, yeah, go ahead.
Sir, suppose actually I have the lose the connectivity to leaf twin spine switches. Is there an impact to the network?
Another beautiful question. The question is, suppose if one leaf switch loses the connectivity to one of the spine switch, assuming the fact that there is a connectivity, there are only two spine switches. Question is, will there be any impact? Answer is no. As long as this leaf switch has another redundant connectivity to the spine, another spine available, there will be no impact to the data plane, no impact on the control plane traffic. Why we have two spine switches? For the purpose of redundancy. We may have more spine switches if you feel that you need higher redundancy. Yes, but there will be impact in terms of latency. Why? Because the entire load in that case will come over here. Why? Because ECMP, equal cost multipathing, will be impacted, right? Otherwise, as far as traffic is concerned, no impact.
In this particular architecture, so who is the actually endpoint gateway switch?
Who is the actual endpoint gateway switch?
Yes.
Endpoint gateway switch, are you asking from which perspective?
So two leaf switches belongs to one VPC, right? So the
Yes.
two leaf switches is connected to the spine switches, right?
Yes.
So who is the border switch actually? So who in particular the switch taking the traffic to the out of the network to the one network actually.
Okay.
So how
So
actually leaf switches will make the decision to this is the outside the traffic to send the traffic to the source to destinations.
So first of your question was the endpoint. I think you add the term gateway switch also, right?
That's it.
In this particular architecture, first question for us to understand is, who is the endpoint here? And then next question comes is, who will be the gateway for the endpoint? Now, if I have understood your question correctly, dear Pitabas,
Yeah.
because you
Yes, right,
used
sir.
some other terminology also called border leaf.
Yes, right, sir. Absolutely.
Right. I am not
Right.
going to take this terminology right now to explain, but I will first of all address this concern of yours. It is indeed a good question. The first question is, who will be the endpoint gateway switch? So before it, the question should be, who will be the endpoint? And our endpoint is here. Endpoint is a server. This may be, it may be a bare metal host server, or it may be a virtual machine, or it may be a containerized network function. I'm sorry to use this term, the term which is used in Kubernetes.
Yeah, right. Absolutely, sir. I got your point, sir.
Right. So for the purpose of the endpoint, the gateway will be in between them. The gateway will be the SVI, switch virtual interface, that will be created on these leaf switches. By the virtue of it, they will present them as one. Endpoint will be the L3 port channel. Endpoint will be a port channel, and the representative of which will be the SVI. The concept, as we did in case of our VPC lab, hope you guys remember. In VPC lab, our endpoint gateway was HSRP IP address. HSRP, standby address, which we specify. So in this case, the endpoint gateway address will be the SVI address for it. Hope you remember our VXLAN lab as well. Yesterday we did VXLAN. Yes, and I promised you that I will provide you another second lab, so that after doing that lab, you will get answer to your question, dear friend Pitabas. Now, in your question, you asked another terminology called border leaf. So the question comes is, what is this border leaf? Guys, I hope I'm not confusing you. I'm just addressing your beautiful questions. Border leaf, you know, what is a border leaf? Border leaf is any one of these leaf switches connected outside the ACI fabric. That is, any of the leaf switch, if you connect it to, say, a world which is running your Cisco iOS operating system or Juno's operating system out of the ACI fabric, that particular leaf is known as border leaf. Border leaf may not be the endpoint gateway. That depends upon where your destination is and how you are connected to the destination. Tabas, does it somehow
Yes,
answer
sir.
your question?
Okay, sir.
Right. So in this journey, dear friends, we are going to talk about the border leaf. And additionally, I would like to tell you, in fact, before telling you, can you tell me what name should we give to these leaf switches? The switch which is
That is called
connected
the
to us.
fiber leaf.
Which leaf?
Fiber leaf.
Fiber.
I didn't get your question. Sorry.
You didn't understand my question?
Yes, I didn't get it.
Okay, and you know what? I have actually messed up this diagram, so let me make a more simpler diagram. This diagram once again. In fact, spine switches and the leaf switches. Connectivity, 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 connectivity. There is a leaf switch. This leaf switch is connected to, say, Junos or Cisco iOS, or you can say our traditional network. Outside ACI. In that case, we just said that this leaf switch is known as border leaf. Suppose you have a leaf over here, and this leaf is connected to a server here. My question is, what is this leaf switch known as? This leaf switch, what name? Yeah.
So leaf 0102 like that, or maybe some names also we can define on that.
Yes, there are certain names based on the connectivity of the leaf switches which we specify. Remember, this leaf is connected to a server.
Yeah, only that is called the server leaf.
Absolutely. You can call
Or
this leaf switch as a server leaf, or yes, one more name,
Endpoints. Endpoints leave.
endpoint, or you can call it as compute leaf,
Okay.
because servers are the synonyms of compute. So you can call this leaf as a compute leaf. One more question. Suppose if this particular leaf switch is connected to a firewall, can you tell me what name should you give? Firewall or say a load balancer? Can you tell me what name should you give to this leaf? We call this as service leaf. So there is no specific dedicated designation to the leaf switches. It is just based on the device they are connected to. We can give them different names: border leaf, compute leaf, service leaf. This is just an extended answer to the question. Okay, we are
That's
going to cover
understood.
this. Thank you so much, Vasio. So guys, there is no specific leaf which has to be designated as border or compute or service. It is just how the leaf is connected to. And one more thing, there is no hard and fast that a border leaf cannot connect to a firewall. If you have a border leaf, you want to connect the same leaf to a firewall, in that case, you can say that this leaf is a border leaf as well as a service leaf. At the same time, this leaf, border leaf, which is connected to a server, can also, which is connected to a firewall and to the outside network, can be connected to a server. Normally, we don't mess up a leaf by connecting so many devices to it normally, but it is possible.
So just to ask again that if a leaf is connected to a firewall, so is it called a service leaf too?
Yes, you can call it to be as a service leaf. Or if you wish to, you can give a new name to it, say hybrid leaf. Though hybrid leaf is not a terminology used, because why we are calling it hybrid? Because it is connected to border, it is outside network, it is connected to the firewall.
Inside. Okay.
Right? So
Okay.
that's the reason. And you know what? In some other organizations, they're calling it as a Tor leaf. Tor leaf is not a terminology given by Cisco. Tor stands for top of the rack. And what do we place on top of the rack? Say servers. So in case if the leaf switches are connected to some compute devices, some organizations, they may call them as Tor, but this terminology will be the organization specific terminology. The compute leaf, border leaf, or service leaf, these are more simpler terminologies to understand. Okay, beautiful questions, and these questions are helping me to tell you and solve your queries. More questions are expected. All right. I'm pleased to have you here, Mahinder Singh. And your full name is Mahinder Singh Kushwaha. Thank you so much for joining, Mahinder. Okay. And thank you so much, Sharif, for joining. Okay. If no questions, no problem. Let me go a little ahead. One more thing I would like to tell you about. And this is about the management. Management means how we are going to configure. There, so far, before ACI, we have learned an hop by hop approach or switch by switch approach of configuring our network. Gone are the days. Gone are the days of hop by hop approach of configuring. What the modern setup says: single point of configuration. We don't want, you know what, in a huge network, how many leaf switches can we have? More than 100 leaf switches. So if you go for a hop by hop approach or device by device approach or individual switch by switch approach, it will take humongous amount of time, right, to configure them one by one, one by one. Why ACI? For the purpose of simplifying our configuration. All those switches should be configurable from one single point of device, from one single point of contact. And that is nothing but that is called a controller. Controller based configuration. This means a controller, you just need to log into it and you can configure. Now, this controller based approach in ACI says that this controller, which is holistically known as APIC, Application Policy Infrastructure Controller, right? This controller, irrespective of whether it is connected to a switch directly or not, will still push the configuration in those switches. Now, let me show you the placement of a controller. For example, we have got two of the leaf switches, spine switches, I'm sorry, and say three of the leaf switches. To configure, to manage this small setup, we have deployed one device, which is our controller. Sweetly, we call this as APIC. This controller has got two of its arms, which means can be connected at max with two of the leaf switches only. Controller is always connected to the leaf switch. Controller is never connected to the spine switches. Kindly be noted. So if this leaf switch number 3 is not connected to the controller, so will the configuration be pushed onto it? And the answer is yes, indeed. Right? Now, another question could be, if this controller is connected to this leaf 1 and to this leaf switch, will it push the configurations at the same time onto both? This is my question to you, and you can give me answer in yes or no. If you want to speak, would be very well. If you just want to type the answer, that is also appreciated. I'm just bringing the chat window in front of me. You can type your answer in front of yes or no, and I will record your answers. Then we'll see where the majority goes. So please, the polling starts over here. Answer is yes, yes, 2 yes. I am recording the answers. Please feel free, guys. It's just a matter of saying Y or N. Hello. I'm sure everyone is listening. Just click yes or no. No harm in right or wrong.
Sorry, what was the question?
Okay, I repeat the question. This is a controller, and the controller has got two of its interfaces, two of its arms connected to leaf 1 and leaf 2. Question is, will it push at a time? Will it push configuration to both at a time? Or in some more simple words, this is going to be active, both the ports, or not? Simple question.
Okay.
Yes. What's the answer? And answer is no. I got one no. Okay. Tick 1. Okay. By default, no. Answer is no. So both yes and no, they are going. There's a tie-up which is happening. One more answer, and we will then decide. Come on, please, one more answer. Okay. Well, answer is no. At a time, only one will be active and another will be standby. And I don't want to tell you further beyond this. Why? Because I would like to show you this in the lab. This is to be understood in the lab, and this constitutes to be a very important question, an interview based question. Based on the understanding of this question, there are a lot of other questions which get popped up. So the very first lab, probably before even starting the main labs, is known as our fabric provisioning, wherein we will understand how the provisioning of this entire ACI fabric, spine, leaf, and the controller connectivity happens. Right? That is a very important agenda. Guys, the time is running, time has run. I have a lot of things to tell you, but not today. Today cannot cover on from one single day, not possible. Okay, would like to address your questions. I have just penned down, waiting for your questions to answer. If you have any question, please ask me. Otherwise, we will meet in the next session. Ashish, Pitabas, Raj, Ryan, Sampath, Siddhant, Syed, Wasiu. Any question, dear friends?
None for my hand.
I just have one question.
No, sir.
Dating
No,
back
sir. I
to
don't have any questions.
All right, Sampath, yes, you have a question. Please tell me.
Yeah, as Vasu asked about connecting both the leaf switches to represent as a single logical switch from a VPC standpoint. And if you're doing that, aren't we losing the objective of ACI? Technically, it's
No,
possible.
because
Okay.
you are right as well, because ACI says no east to west connectivity, but answer is no, right? Well, let me tell you. In order to, if you want to create a VPC, to be honest, right? If you want to bring these two leaf switches as one single logical entity, you don't need this connectivity as well.
Okay.
You don't need this connectivity, but still, because VPC says that you do require this connectivity, which is known as peer link, but ACI says that I will still bind these two physical switches into one logical entity by the virtue of VPC. ACI says that please prohibit yourself from physically connecting them. ACI clearly says please prohibit yourself from physically connecting them, just in order to have a greed of getting peer link connectivity, but I will still provide you the connectivity of VPC. So
Okay. And any
from that
respect to
angle,
looping, that will be taken care by ACI itself?
now in case if by mistake you do physically connect unknowingly, thinking yes, I'm going to create a VPC, then yes, this will be identified as a potential loop, Now, we as an ACI implementation engineer should use one protocol. In fact, during the course of labs, I will ask you to make sure to configure there are a lot of protocols, not this one. I will ask you to configure CDP. I will ask you to configure LLDP. LLDP, which stands for Logical Link Discovery Protocol, is considered to, for the purpose of identifying a non-Cisco devices. But LLDP is configured whenever we configure any of the interface. The moment we configure any interface, we immediately enable LLDP. You know what for? LLDP is the protocol which solves this particular purpose, which ensures that no spanning tree loop should happen. There is another protocol called miscabling protocol. As a network ACI implementation engineer, you are suggested to use miscabling protocol, which also mitigate this. I'll tell you in which case LLDP, in which case MCP, and also in which case BPDU guard we have to enable to avoid the spanning tree STP functionality into it. But it holistically restricts us to physically connect the two leaf switches to ensure one logical switch. Right? Sampath, does it answer your question?
Yes, it's well answered.
Okay.
Okay. I have a question. So
Please.
what you're saying is that in ACI, if you want to achieve VPC, you don't necessarily need to connect the two leaf switches together before you can achieve it.
Yes.
Okay.
So the logically answer is yes. Physically, no. Please do not connect them physically to each other to achieve one VPC, one logical switch. Right? So what is your question, Vasu? Ahead of this?
No any other question.
All right. Then if no question, then let me say thank you so very much for joining this session. In fact, delighted to have you all over here. And we will meet, we'll continue this journey next week. Yes, we have long things to do. I have just given you, just 2% or one single drop of this entire ocean. A lot of things to do over here. And I hope you'll enjoy this journey. Thank you so very much for guys for joining. And good night to all those friends who are in Indian Peninsula, and good afternoon, good evening, good day to all of you, and wish you a very happy weekend. Bye-bye,
Thank you very much for your time. Bye.
Thank you very much, everyone, for your time. Bye-bye.